Archaeologists have been studying prehistoric English monument Stonehenge for centuries, trying to determine when, why, and how it was constructed, and by whom. In that time, we've learned a lot about it. But one piece of information that archaeologists continue to debate is the origins of the stones. Stonehenge is composed of two types of stones: massive 25-ton silica stones known as Sarsens, and smaller stones called Bluestones. Most researchers believe that these Sarsens originated at a nearby boulder field called Marlborough Downs, which lies roughly 15 miles from Stonehenge. However, others feel that the proximity of Marlborough Downs does not necessarily explain the origin of the stones. After all, the Bluestones, which have been more extensively studied, are thought to have originated some 100 miles from Stonehenge. But a recently studied artifact brings new information to this debate. In 1958, a man named Robert Phillips was part of a crew hired to re-erect 3 massive Stonehenge stones that had fallen over a century earlier. During their work, the crew discovered a crack in one of the stones, and in order to insert a metal bolt for reinforcement, they had to cut a hole through it. Phillips kept the drilled-out core and hung it in his office as a souvenir. In 2018, Phillips returned the core, giving scientists an opportunity to closely study this piece of Stonehenge. You see, destroying intact pieces of Stonehenge is currently illegal. Using a portable X-ray spectrometer, a team of scientists took non-destructive surface readings of each sarsen. They learned that these stones are over 99% silica, but with traces of other elements. And when they looked at those trace elements, they learned that 50 of the 52 sarsens have a nearly identical chemical composition, suggesting that they all originated at the same location. Because the Phillips core was no longer an intact piece of Stonehenge, they were able to run it through more extensive and more destructive chemical tests. They compare the results of those tests to tests on samples taken from boulder fields across eastern and southern England. The researchers found that the Phillips core matched with samples from West Woods, a forest within Marlborough Downs, giving stronger credibility to the early assumption about the stone's origin. This serves as a good example of the scientific method. Scientists form a hypothesis based on the information available to them, but it takes specific and detailed testing to better support that hypothesis. If you liked this video, remember to like, subscribe, and comment below. And for more information on COSI, Columbus, Ohio's Center of Science and Industry, visit cosi.org.